Hello. I'm gonna do some drafting right now, I think. Did this not create? Um, hmm, Strange. It doesn't want to complete the. It doesn't like. It doesn't seem to open anything. Try that again. Select. Oh, okay. Did it that time. Step 1, 2. Handle tool tray. Handle and tool tray. And it should have made a total for that, I think. Oh, maybe it doesn't do. Maybe it doesn't do just an individual thing. This. Can I do a drag and drop with a step file? Oh, I guess I can't. Strange. I guess I could upload it. Give that a try. Select files. Oh, there it is there. I'll try both of these. See if it's in Zem. This is trace. EXF. I know those are there for sure. So tool tray V9. Okay, good. So handle has its own thing, and then the actual body of this is by itself, which is great. Handles off, and this other. So if I was to convert that to sheet metal, it should unfold no problem. Okay, so sheet metal, convert to sheet metal, and we're going to unfold all bends. Yep. There it is. Well, that's pretty cool how all of that works. That's pretty cool. Get rid of that. And let's try this again. This was an STL. Oh, it actually changed it back. Okay. Delete. Yes. And delete this one as well. Oh, it saved at 11:11. How cool is that? I didn't even notice that. And the AM. One of those people that sees 11:11 everywhere. Kind of fun, isn't it? One of the amazing things. Synchronicities about life, the universe, and everything. We got Amazing. Got me caught. Little wormhole scroll. It's blurry. That's all right. Let's make some drawings for that. It's gonna do this one here. Actually, I want to crap. This is always the problem that I have. I want to go and group shit together that I probably shouldn't. And it's all the naming stuff, right? Oh yeah. So this should technically be assembly. So tool tray and then assembly, right? If that's what I want to call it. This can go bye-bye. And if I wanted to create a drawing, inch, A, portraits. These are just basic drawings from scratch, ASME, full assembly. Okay. Let's try it out. Tool tray assembly, see? 1/8's probably okay. Ugh. Get out of here. So instead of material, quantity, item, mass, description, and I don't have any. So item, there's 3, 1, and 12. I don't see how there's 3 of anything in here. Oh, the hem. Yeah. None of that. And number 2 is the handle. Yeah. And the body should also be 1. And I need to include everything. 2, 2.1. Just 2.1. Which is also the hem. There we go. So item 1. Does this not include the major part? There should be 3 things on here, but there isn't, because this is not included. So 1 is the handle, right? Yep. Tool tray assembly. Can't do that because it's in here. It's kind of shitty, isn't it? So we're going to export. I guess I could just export the handle. So a lot of the times my brain doesn't work right and I don't put everything in their own component, which they should be. If you're creating an assembly, it should be like that's the top component. So if you're making a top component of that, it's not going to include its own body, which makes sense, right? It's only going to count what's in the drawing. So I'm going to call this tool tray, and of this I'm going to say, can we do an export? Tool tray is going to have a handle. see if this works correctly. So I'm just gonna drop the tool tray in here, right there, ground it. Yep. And I'm gonna make a new drawing. Inches A, full assembly. So of this, no hem and no hem in the handle, no hemming and hawing. So the handle and this, but I still don't get the actual tool tray itself. Should be all, let me see here, all level. There we go. So tool tray, the material, has mostly materials because there's mixed material in this, or I don't actually have it set. So let me go back into the tool tray. This should be steel though. They're both steel. Oh, it's steel plain. So let's do description, part name, item quantity, part name, mass. So parts list for that on top. Steel plain. Ounce mass. It's pretty light. So 1 is the main component, 1.2 is the handle, 1.3 is like the little stuff that's in there. And it's strange to have to do this, but that's the kind of rationale that's behind it. Now, if you didn't want these things like 1, 1.2, 1.3, you just wanted them as like 1, 2, 3, then you have to split them up into different things. But I think that's fine just for what this is here. And this is like a general overview, like this one here. So tool tray assembly, I could just call this assembly. Assembly. And then I should be able to can't I regenerate this? Reset. There we go. So tool tray assembly. I could say assembly overview too, something like that. Man, CAD's come such a long way. That's awesome. Close from that. So then we can just detail these things here. 10 inches. We could do these ones here. The bottom is like 3 inches. Might save this as a I want it fractional. I want it to go to a 16th because we're not going to do anything more than that. 1 degree is fine. That's great. You could probably get away with a little bit smaller text. Okay. Smaller text is a little bit easier to manage. So that's a similar type of thing. We can do, just update that. Let's do some magic drawings. So now I have sort of idea. We can do a center line for these. These are, so by doing the center line, it's saying, okay, whatever I put on here, it's symmetric, like side to side. I could call it that. Oh. So the clearance between the top edge here and the bottom of the handle. I think I want to do the thickness of the handle. Oh, I forgot to do the, not the inches. I guess we don't really need the top one, but just throw in. .24, and that can be changed to whatever we want. Hey, there's two holes in here. Where are they at? Plus. And when it's 64th, I forgot what a 64th is. 1565. That's right. 01565. And same with this one. Edit. The automatically select derivative is too small for this geometry. No, it's not. Auto update. Usually when I go a little bit larger, right? A number 30 drill. 1285. Here we go. Update. That's 2 times you asked me, Dr. Dre. Really want to make sure I'm okay with that. You don't really need the angle, but I'll give it to you, I suppose. So 67, and then also 23 if I can get it up there. There we go. Something like this. That one's not necessary. This is all the same. 3 and 3. Full here. And then this is, might need to be decimal, but it's just the smallest available, I think. Maybe we can do something a little bit more conspicuous. Why? .3. There we go. Clearly pointing to the one side. And then this side here will do. How much clearance there, or how much clearance there is between the handle and here? It's 1 inch deep. It's 1.5 inches wide. So here, 1 3/4. Apologies. You're not supposed to double up dimensions, but I'll save. Remove, delete the sheet. Ah, that's why. Hey, welcome to the stream. How are you today? Not too bad. Chipping away at a little bit of work here. I'm kind of in a, I don't know, zombie mode maybe. It's I'm just trying to get going here, trying to have some fun. Drawings are, they're fun, but they're like boring at the same time. So it's just a necessary evil. What are you up to today? What are you working on? Do you use Fusion or have any, or drafting or anything in general? Tool tray. Oh no, that's too bad. Yeah, it's one of the painful things. You spent your first hour in Fusion 360 and it crashed. And you lost the whole model. Yeah, that's horrible. Oh man, I reread it just to like make sure I didn't read it wrong. Yeah, one of the things I learned really really soon is just like save like every major action in Fusion. That sucks. Yeah, I've been there. Yeah, losing an hour of work is go for a walk sort of coping. Ah, cool. Yeah, used Inventor and AutoCAD a lot in the past. I did structural steel work for a long time, so I used Tekla structures for the most part, but I used a lot of AutoCAD with that too. And that was also painful. Yeah, so it, it would be kind of like drawing structural steel in Fusion or anything else. It's horrible. Not streamlined, but yeah, Inventor's really nice. I'm missing some features in Inventor for sheet metal that are not available on Fusion yet, and I really hope that they I don't know, expand the library of tooling in Fusion for sheet metal, and even maybe make some new stuff because there's other programs have other things too. Really starting to like doing sheet metal work. Actually, like working with it too. So that's the other thing. Just for your hobby stuff, not for work, but you like to get into it a little bit more. Yeah, it is really fun. Um, it's it's an easy way to create things, like or sorry, to be creative and not have to spend a bunch of money on it like right away. You really like flesh out an idea um, and iterate over your design pretty rapidly and cheaply, not including the time, obviously. That's cool. What kind of hobby stuff and projects do you like to draw or like to utilize Fusion for? What was I doing? Oh yeah, I want to do a drawing just of this drawing. This is going to be a bigger one. ASME B. I'll just do selects. I guess I'll do just the body here. 3D printers, CNC. You might use it for so far. I used it for parts. Oh, for your car and your drone. Nice. Okay. Yeah, I like drawing car parts. Car parts is how I or what I first used when I did CAD work at the beginning. Going back all those years. Let's do front. Shant's really making a similar drawing, but it's only gonna have just the sheet metal and no fasteners. Use the shift. Can't I deselect them all at once? Oh man. Those little things that I miss. Alright. I don't need that. And second sheet is going to be flat pattern. Can I do 5? 3? Yeah. 4. Okay. And bend table. Oh boy. I can't do it this big here. 5. Oh. Reset properties 1 to 5. Oops. Is it possible to use Fusion for CNC cutting? Oh yeah, yeah, absolutely. There's a whole manufacturer system with that, and we could do so like this tool tray, for example, should be able to do a there we go, the flat patterns. There we go. So like if you have the, like this is for like laser cutting or water jet or something, you can set this up as like whatever machine that you want. So this would be cutting, and then you can go through that whole thing and set that all up. So like whatever the coordinate system of your machine is and all that. Yeah, you select your model. It'll set up all that stuff for you, and then you can actually make the path. And if you had multiple things, like multiple things set up in your thing, you could auto nest it as well, which is really powerful. And I think they have a more advanced one that you can actually buy like as an add-in. Don't 100% quote me on that, but yeah. You'd have to go digging, but yeah, definitely worth it. There's some pretty good time-saving tools there if you were to use this as do a laser inches, 40 thou, nozzle. This is for water jet, probably 125. It's probably 100. Select a tool. Oh, no filter. Okay. We'll just do laser. Good enough. 39 inches a minute. That's really slow, but I'll just show that so you can see it. And I haven't done any of this in like ages. Holy moly. There we go. There's the path. Is it to simulate? Yeah, there we go. So yeah, it simulates all the path for like laser cutting. So all the tools, and slow right down so you can see it all. There's like all the different settings is there, and it's pretty cool. Yeah. I think that's like the fun part about doing work like this, or you set up like the whole DXF or the whole CNC file and ship it off to somebody. It's pretty fun. Exit simulation. So, all right, let's design. I use the bottom part as the flat pattern. So, actually, I'm gonna double check that. Yep. What are the orange lines? Is it just gonna cut there or just move? So the blue is actually the cutting line, and the orange are it's the just movement lines. So these would be like your rapids. So it moves up and then over. Yeah. So just where all the tool head is gonna go. So I'm gonna change this on here. Let's do edit. Models. Body and this one here. Okay. Nests, generate. Should do a. I always forget how to do this in Fusion. Anyways, I won't spend too much time on it. That's not my field of expertise, machining. I know how to do the basics, and that's about it. This is designed just for like a folding, like a box break. I guess if you have the right machine, like the right tooling for like an airbending, you can do it on that too. This is just 20 gauge material. It's pretty light. So yeah, these plans are made for that basic sort of idea in mind. Yeah, like it's like a first project. Make like hobby plans to sell stuff, and this is just like it's one of the things that comes up as like sheet metal projects for beginners, and that's I think that's kind of nice. It's an old timey thing where it's like you make a lot of your toolboxes and stuff for back in the day, and then like everybody has stuff like this. It's pretty cool. Hey, awesome, dude. Yeah, welcome to the stream. Appreciate you coming by again. Yeah, that's cool. Did you get some of the problems that you were having solved? You mentioned you had some issues in Linux. Fusion and a Linux crashing or something like that. Or maybe not crashing. That's probably just my assumption. I don't know. Yeah. Oh my goodness. Slouching like crazy here. What was I doing? Oh yeah, sheet metal. So this drawing here is doing excellent. Serious concerns that you may be mentally handicapped? Nah, you're not mentally handicapped. Probably maybe just a little bit of inexperience. That's about it. Like some of this stuff's got a huge learning curve, right? So yeah, don't feel bad about that. What do we got here? So the bend chart. Usually I would like to see how these dimensions work out. For air bending, it's just the back gauge to the center that I'm usually worried about, because it's just positioning where you want the straight die. But for folding, you want to have I don't even know if it does this or not. If it's a sharp radius, then it would be usually you have like a sight line and all that stuff, but if it's sharp, it's Jesus, jogging my memory now. I haven't done this in so long. Let's see here. No, I don't run Linux. It's just Windows. Is the software quite a lot different? I've never actually used Fusion in any other environment except Windows, so I don't know. Yeah, a lot of the time, like when I'm doing sheet metal, I always assume that everybody has a CNC bender or with a back gauge, and that's just not true. So I should probably detail it maybe both ways. Yeah, for material this light, I don't think it actually matters that much. So if you were to put it on there, it would fold over. So you actually want it to start here. This would be the edge, and then it would bend over. So you would want to have it at this one here. Let's do a study for that. So if I was to draw, actually I'm just gonna do this here. Turn off this, go to the front. Trying to use FreeCAD, but I pretty much just want to be able to make our own custom models. For some reason my brain is glitching out. I'm getting past the drawing portion of creating a 3D model. You mean like the actual sketching and constraints and stuff like that? Is that the idea? Okay. So usually box break has like a table for here. We're gonna have 0.075. That's the gap in the table, or where this actually starts going. So here's the box break, or the break edge is right there, and then it would go up. So the clamp needs to be, so if the clamp was here, like the finger, it holds that on there. Is right there, and then this travels along that radius. So the whole thing here. I think that makes sense. Yeah, the beginning part. Oh yeah, I can take it through that if you want. Is there anything like very like do you want me to just like give you the kind of the basics? I could do that for you. Totally fine. I don't mind. I'm here. That's what the stream is for. Edumacation. So let's do. That's kind of what I'm doing right now, actually. Oh dear. Oh no, this component, I did that in 2 shots, only 1 shot. So this can be its own thing. And then this one here should be its own component. And then I'm going to as build joint this. Revolute. Can I do this around a sketch? No, I can't. Okay. Joint. Oh no. There we go. Things that I'm doing just for looking at stuff here. All right. So that's kind of the idea I would think for that. That makes sense. And this is just going to resist this area, and that's just where it's going to go. So, and then you would bend it, I don't know, probably like 4 or 5 degrees past. You get back to drawing, starting from the beginning. You're drawing a battery holder for your drone. Oh, cool. Okay. This time you save the progress. Yeah, absolutely. Yeah. Save it every like a couple minutes or something. There is a setting, I think, for autosave. If I'm not mistaken. Where is this here? You got to save it like first, and then it'll autosave for you afterwards. Pretty sure it's like every like couple minutes or something. And then if you ever have problems in the future, you can always recover that drawing too. There's a way to recover stuff. Where is that? Okay, it's just in general automatic. Preferences. Yeah, every 5 minutes it makes a backup recovery. So if you automatically close it and don't save it, then you do that. But if it crashes, you can get you're only going to lose 5 minutes. So the timeline at the bottom here. Okay, so if you start a drawing and you don't have this shown, what it is you don't have, if it looks like this, you need to go to here and say capture design history. So then that'll give you the timeline. That's if you're not using it, you're just using direct modeling. It's just another way to think about modeling, more like using AutoCAD. And then there's some more stuff down here too. You could say do not capture. I'm pretty sure it's in this one here as well. But you have to go to here to activate it. If I'm not mistaken. Yeah. The assistant's actually pretty nice too. If you ever wanted to like chat with it, if you had questions, it'll point you to the right direction. In the right direction. Or you could use like a language model, stuff like that. They're all trained on the documentation, so it should be easier to ask like a general question like that. So yeah, the design history, and then you can do whatever you want with that. So yeah, back of the bend, and then how big it is. So this is number 10. That's typical for all hems. It's just probably 5.4 from the edge here. Oh boy. Yeah, it's just time. That's all it is. Yeah, I've added enough time to figure out where all the things are. That's it. And stuff gets pretty like you'll remember stuff as you go on pretty quickly. Let's do the overalls here. How big would I need to make the material? And I go to here. And I'm also going to do symmetric. Well, center line anyways. So usually if you put a center line on this, or how I think of this, is this means, it doesn't mean things are like absolutely symmetrical. It just means that these reference lines are in the actual center of the part. And I'll just make a note. It's like all these here are the same in all four corners. Or similar. Yeah. Do like the overalls. 49.02. This needs to be units. Fractional. 16th. Not inches. That's a little easier. If it needs to be symmetrical lines, you run with a mirror. But yeah, you totally can. For this, it's a yeah. Is that not okay? There we go. It's 9/16. Let's see how far this actually goes down. Maybe it should be in. Oh yeah, it is like a strange number. So in fabrication, let's see, what's the typical? Sixteenth quarter, 10th precise work. Yeah, I've never seen sheet metal made to 10th, but I'm sure it's possible. 10 to 30. Yeah, material thicknesses. Yeah, this actually isn't a sketch. This is a drawing. But yeah, you're absolutely right. Like when I did the tool tray stuff, way at the beginning. I go back here. Roll history. I only designed a quarter of it. And that was pretty much like for everything. So everything that I did, it was just to this like piece. Actually, I did quite a bit of it. Whereas my first mirror was here to get that edge, and then I did a few things, and then I mirrored it again, even the handle up at the top. So that was its own mirror, and then did the other total to fix the rest of it. Yeah, absolutely. All right. Yeah, that makes sense. I was just trying to like, how would I want this detailed for this here? So that should be that's the top or the inside radius, and that is 0.039. So it should be 0.039 on each side of that. That makes sense, right? It's gonna change this to decimal for a moment. Decimal. Let's do 3. Or is this the outside? So it's 0.06. Oh, that's for the hem. I'm sorry. And then these here are, yeah, so 0.059. Okay. Let me see if that corresponds. That will be oh, that's the radius, not the circumference. Can I do arc length on this? I think I can. Uh, 0.061 length. Yeah, 118. Okay, good. 61. Ah, interesting. So 118 would be the total, and it's technically in the middle of that. This is actually a demo. This is a demo version of the full. It's a demo version of Fusion, like a trial version. I'm just trying to get a free month. I did subscribe when I was using this full time as a engineering program, but I do not pay for it right now. So it's just a few trial. I got 21 days or so left on this, but it's like the full blown version, and then maybe back to the other. But if I start to do work, that was a couple of years ago I did that. So if I do work like this professionally again, then yeah, I'll buy it again. But I might get something else, or I might use Inventor or something like that. Yeah, exactly. The student version is fully has all the features. And then this should be more because it's a full bend. Yeah. So 121. That's the full outside. Is that actually how that works? Oh my goodness. Got some crud in my eye here. There we go. Eyelashes. Yeah, I have to have a use case for it. If I was doing, I probably should buy it anyways, just like for the amount of time I'm using it. It's worth the money, I think. Then I kind of I want the hobby to kind of support itself too. Like that's how I look at stuff like that. But like even if I wasn't, last year I had a copy and I barely used it, so that's why I didn't want to buy it again. So I don't know. Well, it was really expensive. They jacked up the price quite a lot this last time, but then they 30% it off instead of whatever it was before. I forget what it was. But yeah, like I'd make that back in one job. So it's not horrible, but you got to do a job or two for free. And if I used Inventor or the mechanical design thing, oh geez, what's it called? There's like product design and manufacturing collection. Stay is $410 a month US, or $32.65 a year. So I have to line up a couple jobs in order to buy this for an entire year. I would like to have at least two, so that's, I don't know, 25,000 or something in revenue to support that. And just throw in some like basic base numbers out. And sometimes they're there, sometimes they're not, but like contractor work gets pretty stressful, so that's why I don't do a lot of it anymore. I like to do like smaller types of jobs, or like job shoppy type of work. That's kind of fun. Maybe I'll buy a machine and then just do like sheet work like this, and maybe some bending and stuff. Maybe manufacture a product or something. I would like just to sell plans. That'd be fun. That's the main goal. That's all I'm doing now. So, all right. Try and get people involved and have. There's always something for sale, right? Okay. No, not that one. Everything looks legible. I do like to have the arrows and everything. No. Here. I wonder if anybody's detailed this stuff here. I know the sentiment is anytime like the shop guys get drawings for sheet metal, it's never correct for whatever reason. And structural steel's kind of similar, but like unless you're using a specific program for that, it's just all streamlined for the way the guys like it in the shop. So doing this in a general sense, should probably do this for both airbending and for the just to draw it out, I guess. This would be nicer if it was larger, like a paste on template. I've done that for people in the past too. They just print it out full size. Like they have like a 48-inch printer and they literally just print out a 4-foot wide piece of paper and paste it down to the steel and do it that way. The lines are within 3/1000 of an inch usually, and that's I guess that was plenty of space for them. It's wild, man. Cheap viewers, hey man, the cheap view people showed up today too. Thanks for stopping by. Appreciate that. The band words, yeah. I should probably do that. It's a good idea. Thank you. I'm gonna make that a sticky note right now. Like automatically bans them, sort of thing, or just filters it out. From the viewer. They keep getting new stuff. Oh yeah. So I had it happened yesterday too. Well, it happens every stream. I just yeah, to kill the spam. I guess what I thought yesterday was if it wasn't for them, nobody would show up at all. But that's not true. There's like, you know, a few people that show up every day, and that's like kind of what I want. Especially like learning the ropes and getting used to streaming, being on camera, talking a lot again, or explaining things. It's nice just to have any sort of activity. It's kind of funny. So I just use that as an excuse to talk. Banned words and phrases. You can just copy paste. Oh, okay. They use weird letters and go around their blocks. Oh, okay, gotcha. All right. Copy pastes the words they use. They probably change them all the time. If I was trying to think nefariously, it's like, how would I get around that? It's only going to get more sophisticated as time goes on, right? See a full hem. All right. By 22 to the center. This would be a full round over, and if it was here, you go all the way to here, and then you crunch it down, and it should be right at that same level. It should be the 082 plus a little bit. I need to. This is steel, so it's 4.4, I think. Hopefully, I did that correct. Let me see my sheet metal rules. Oh, which one am I using here? Bodies, flat pattern. Steel millimeter convert. Oh, which one though? Oh no, it's the wrong K factor. That's not gonna work. Steel. I knew this would come back to bite me. And then also the handle. Why was it using 0.44? That's why. So that's the default, that's why. Okay. Where is... Oh man, I can't believe I did that. There doesn't need to be any of that there. You just found out, okay. You had autosave on? Where do you find your drawing? I'm so lost. As long as you, actually, I'm trying to remember. I don't know. I don't think I've ever recovered a drawing that I didn't save. So it's untitled. It exists, but unless you save it, I don't think it actually puts anything on your computer. And I don't know if it saves it or not on the cloud. Yeah. Let's see here. Just searching here. Yeah. Autosave does not work for a new unsaved document. You must manually save the file at least once to initiate autosave functionality. Yeah, that's how I thought it worked. So that's there. Once it kicks in, recovery files at whatever interval. Yeah, save early, start with components. Good general rules of thumb for using Fusion. So always create a new component. It all depends, though, I think. That makes more sense. Why that's not doing its thing. This should be a little bit longer because it's not the actual outside radius, because that was showing 1 for the unfold, but it's actually not. It should be a little shorter. Because if it was all the way up to here, it would be like a square sort of corner, and this is less than those two squares. There's less distance there in the corners. Good thing I caught that. Updates, flat pattern. I have to resave those two. Flat pattern. Exports. Inches. Save to my computer. DXF. Where did I put you? Was it in drawings? Yeah, it is. I'll just resave it. Export. Inch. I want this as tool tray flat pattern. Yes, save. Yep. Finish and do this other one here too. Export. Inch. DXF. I want to choose handle flat pattern. Yep. Yes and yes. All right. So this should also be updating. Sorry, I'm flying around here. Save this, and then I should be able to update it. Hopefully it doesn't die. Tool tray drawing. Yep. Maybe it updated already. So this should be shorter, 121. And this should be, so first setback I think is, it's 0.036, and the radius, whatever, I use that. So it was probably, this one. That's the one. That's in millimeters. Didn't I have it in, I think it was Zometry. That's this one here. Yeah, there we go. It's an actual, whoever designed this like chart, it's interactive and it's pretty nice. I was using, I'll throw this up here if you guys ever want to use it. Very well done. Yeah, I was using 20 gauge and 039. So pretty sure I was using, yeah, so the inside radius was 339. And what was this, the forest chart? Yeah, 3.6 tons per foot. Force per foot. Yeah. Hey, thanks for lurking. Appreciate that. Right on. Yeah, thanks for dropping by and hanging out. Yep. 0.39. So the this is for air bending, but I would imagine, can I change this to, oh, that's cool, you can download the PDF as well. Do they have a folding section? This is all air bending. Minimum radius for sheet, yeah, okay, I think it's just going to be for full, V bending and air bending. Oh my goodness. Let me draw it out here. So on this particular edit sketch, sometimes I get confused when I don't do stuff for a while and I got to reteach myself. This inside radius, 0.039, so that's correct. And this one here, arc, 0.075. So the setback from here is the radius plus the, I have it set at just the radius. So the design setback, it was 0.039. Radius and the length of that is 0.061, which might actually not be correct. That's what I want anyways. I did draw it. Yeah, 0.061 makes sense. I have arc lengths. Brilliant idea of using copper tape. Copper tape because you don't have proper PCB for what you're doing, and you're broke, so not the best choice. Not the best choice of what you've done. What's the you're making a light? Interesting. What is that all for? I gotta look into that. You know, it's one thing I really haven't explored too much is the electronics. I really should. It's such a powerful portion. Foldable dimmable light for an action cam. Wow, cool. All right. What we got here? Airbending. Yeah, bend allowance. Arc length of the neutral axis through the bend. So that unfolds. That's the length that we use for the extra piece. So if it was, if I wanted to just do these through here, this would be the formula is 90 divided by 360, so 0.25 times 2 pi, oops, times 2 times pi times the radius inside a radius, so 0.039, 0.39 plus K factor 0.044 times the material thickness, which is 0.036. And then all of that is negative because of how I'm bending it. 0.086, that's not right. It would just be, what do I have wrong here? .039. And I put 2 in pi. It doesn't really matter. I'm just going to do this like this. R inside radius 0.039. 0.036. That's correct. Why is it so big? Or did I do something wrong here? .086. Oh no, that's the arc length. Oh, I'm so dumb sometimes. No, no. That's very simple. Very simple. Running a crude potentiometer and a single MOSFET for the dimming, so like a slider, right? Sliding. Not the right way, but it's such low power. It's fine. Oh, okay, that's cool. Would you typically use like a resistive like strip or like something like that? Oh, you just tune. Okay, gotcha. Standard potentiometer. I know like I know lots of stuff about electronics, but never physically built much, which is strange. When I was a kid, I did a lot of like car stereo and audio like stuff, like lots and lots of audio stuff. Built lots of speakers and speaker boxes and all that stuff for car and home. Crossover networks is about the as much electronics as I've done, which are like basic circuits. Nothing too crazy about that. But I haven't done this stuff in so long, and there's so much available now. Yeah, it's really cool that you're actually building it. Okay, so that's corrected. It is 0.086. 0.086. It's big ass long thing, but what I'm doing is not correct. Actually, I should just keep that there for the time being. That's the arc length setback, or the bend allowance. So 0.086 should actually be the total length here. Well, at least for this. So 0.086, which is not true for 90. And it should be. So why is it 118? It's 118 because, oh geez, talking through my stuff here, which is the arc length of this outside, right? 107.5. Yeah, there's something wrong with this. Oh, inspect. Yeah, so 118. That's the arc length of the outside, and that's for the 1-to-1. That's not correct. So maybe I need to remake this one. Do we have... Can I actually update this table? I'm gonna make another one. Oops. Yeah, get rid of that. MOSFET is basically like an adjustable relay. So the amperage goes through that instead of the potentiometer. Gotcha. Doing this gives a pretty good voltage drop over the MOSFET, but oh well. Okay. Yeah, I really need to look into like all that stuff. MOSFET, I've heard that it's like amplifier sort of thing, right? Adjustable relay. That makes sense. I forget what MOSFET actually is. All I know is it's like a transistor. MOSFET. Stop. Field effect transistor. Okay, transistor. Oh, that's way more information than I wanted. You gotta love how easy it is to get information. Holy moly. Fast switching, okay. It's a type. Gotcha. Yeah, that makes sense. Excellent. Jogging my memory and brains and stuff here. What was I doing? I was gonna create a new drawing. I have tool trays saved, I believe, with the new rules. That's a hem. The flat pattern. Just gonna activate this here. This should be I guess I can just inspect. That's the total length of the cut. Okay, so that actually is correct. So I said 0.086, right? From before, I'm pretty sure. I here to here, 0.081. These are 90s. Why would that be larger? That doesn't make any sense. Is it 5.8? So rebuild. Okay. Convert 44 4444. Okay. Update. Activate. Okay, that's better. They look really similar now. I 86 86 81. Oh, it's probably selecting something else here. Those should all be the same as far as CAD goes, right? 8.1. Sorry for the flashy. Oh my goodness. Come on, mouse. 8.6. 8.6. 8.1. Maybe I did that wrong. Or I have an override. Yeah, that's a lot of my knowledge too. Learn the best I can with whatever project I'm working on, and yeah, oh shit, no. I let the smoke out. Not good. You don't want to do that. It takes them years to get that smoke in there. All right. I was going to double check some of my folds here, see if anything is overridden. Let's go all the way back to here. So edit feature, override rules. No, all of this seems right. all the bend should be the same for this. So this same bend here is actually used the bend 0.036 should be the same 0.039. Ah, all right, okay, so that's where I went wrong. Why is this one using, let's roll back all the way to here. .039. These were created with a fillet instead 0.75, which is maybe not correct here, because I have 0.039 that outside radius, the inside radius plus 0.039 plus the thickness is maybe not correct. It makes sense though to have it that way, but theoretically it's not working out for whatever reason. So 0.039 is the radius, and then this one here, let's do this one here. I wish this was a different thing. B, I guess. Because this converts, these were two converted for the bends. And they should be the same, but they're not, because the how they were created. So this is just coming back to bite me in the ass here. 0.039 is the inside bend radius that I used for this one, but the other one that I chose to do here, this one here, is not the same. This is 0.036, which is the material thickness, and I need to make that larger. So the other ones are correct. Override rules 0.036. No, I did it again. 0.039. 0.039. 9. There we go. So 0.039. And then that radius is 0.075. Alright, that makes way more sense now. And this should still be 10, about 10 thou. Okay, it's 13 thou now. And I think I did the math wrong when I did that one there. Alright. How not to do this. Okay. So go back in. So 3.9, 3.9. Oops, 3.9. Okay, good. When you made your car key tester, you burnt a couple capacitors and resistors. Yeah. Oh yeah, it's I've let the smoke out of a few things, and I've seen other people do it live. It's just like, why did you do that? Why did you touch that? There's one memory that I have, and I the poor guy, man. He didn't know what he's doing. He's like, oh, what's this? And he just like goes and plugs it. I'm like, no, don't do it that way. And then he just like, it hadn't been checked and all that stuff, and he just went and burnt it. Oh man. Thankfully, things sometimes are not our own money, but you know, somebody's got to pay for it. You know, company absorbs the stuff. Oh my goodness, poor guy. He felt so bad too. We didn't have the extra parts and all that stuff, and we had to wait. He bought donuts, that's for sure. Finished my yogurt and berries. I'm going to turn this off and double check all the stuff that I did up here too, because this is probably wrong. .36, yeah, it is. That's 3.9 is correct. So the automatic one that I did is wrong. So we go into the rules, sheet metal rules. Bend is not the thickness. It's going to be I guess, well, 0.039 for this one. Oh, it's in millimeters too. 0.039 inches. Hopefully that's correct. And steel. .039 inches. Save. And okay. .039. Yep. Those bends are drawn in. These ones here should be good too. Yeah, this was a really good exercise, just to not only to create stuff, but also to really get into the swing of checking things and making sure they're right. And just correct in general. So did I do, where is this? Let's go edit, and maybe not edit, just show the dimensions. So I drew this out, 0.039, and this was this D15, D13, D15 is this one, because I drew actually drew out the radius of what I wanted. 0.039, and then if we were doing the actual allowance is 4 of that. It's not, I believe it's not the same. Of what this is here. So when we unfold it, well, actually it's when it's drawn to this, when it unfolds, it should be it should account for the shit, I always forget the language here. My goodness. Words, not words difficult today. It's the arc length of the, I want to say centroid, but that's not the right word. Centroid is something else in engineering. Neutral axis. The arc length of the neutral axis. All right. Metric. You're using metric, not freedom units? What's going on here? I like to use both. It actually depends. I use them both. I use inch for this because it's all the materials that you buy are typically an inch. But that's not always the case. Depending on what you're doing. You're doing anything in Canada for government work. That's where I'm located right now. You do government work, everything's in metric. Even the materials are in metric, which is even more crazy, mind-blowing. So a lot of the material choices are for that. So you use metric blocks, you know, and. It's really funny too. The crew people, like I'm remembering a project, and there was a lot of hemming and hawing because nobody had a metric tape measure. So the company had to go out and buy metric tapes for everybody, like everything, even the long ones, like I forget what they were, 100-meter tapes and stuff like that, huge long things. I remember the boss like says like we should just buy a total station and be done with it, you know. Everything's in everything. You're not wrong, so it's really funny. But just like to have I think it's easier to call out instead of it's like, 3/16 or whatever. It's 3 mil, or it's 4 mil, or it's 4.5. Like you're not gonna split millimeters on like construction job, but you'll do it and maybe work like this. But even 0.5 millimeter is really small. It's like a scribe line, And then on top of that, you gotta have good eyesight. Yeah, everything's metric. Yeah, absolutely. So typically everything is done in metric in Canada too. Like that's what they teach. But when you go to trade school, they teach you both, because everything is still built. Like all of our material sizes are, it's like 8 feet long or 4x8 or like 10x10. Like everything is just in feet and inches for standard stuff. But that's changing as time goes on. One like a Home Depot or a Lowe's starts selling everything in metric, then everybody will just change. We'll hate it for a year, and then it'll just be normal. Counting to 10 is far easier, but it's harder when you go to divide 10. So now you have 5, and 5 doesn't divide into anything really easy unless it's that. I'm going down. 1/2 inch. Yep. Slightly smaller at 12.7. Do you have about 13 millimeter often? Oh yeah, okay. Oh yeah, makes sense. Yeah, you're just like, or you just tap it on there. It's always good. But like, what's really really baked my noodle when I found out this is that prior to World War II, there wasn't an actual solid like basis of precision measurement for like anything in the United States. It was just like all willy-nilly. So it's like everybody's inch was a little bit different and all that, till we had like gauge blocks and stuff like that, and like, this can't be right. And it's like, no, that's actually how it was, and it improved everything. So like modern engines and everything else are because of that tolerance. They just need to, not the tolerance, the gauge block sets or something like that. So like the standard manufacturing stuff was built on the exact same thing over and over again. It's we just take all that stuff for granted now. It's something else. And like we can buy precision like measuring tools really cheap. Like I think the caliper that I bought was like $20 or something like that, and it's good enough. Like it literally is good enough just to do like basic stuff that I do. If I was a machinist or whatever else, I'd buy more precise tool or higher quality tools, but if it gets the job done, I do more CAD work anyway, so I don't really have to worry too much about that stuff. But I would love to have like a 3D scanner. I wanted like an Insano one a few years ago. It would have been great. They're almost $100,000 though for the one I was looking at, because I was considering about doing metrology work with it, which needs that level of precision and repeatability, accuracy and repeatability. All the clouds are gone. Nice blue sky today. I have to remember to go for a walk or do something outside today. I work on my car a little bit later. Got to change the battery out. Get all the stuff ready. It's been sitting all winter, so check all the fluids and maybe do an oil change or something. Check the tires, take it for a drive. Yeah, check the brakes, all that stuff. Maybe bleed the brakes. It should be okay. So yeah, 0.075, that's to draw this, and then when it actually unfolds, that should be a different number than what's in here. So these two, it's going to be, yeah, it's not going to be 0.061, it's going to be the 0.8886 or whatever I thought it was before. Maybe I could draw this out here. Edit sketch. I still have, oh no. I don't have the thing. I copy and pasted the MOSFET over. Destroyed the other thing that I had. Okay, so got the understanding. Fixed all that stuff up. I'll just close that down. So these are all 0.39 as I wanted. That's the smallest from the chart. Smallest from the chart, or the radius I want. We can go to 0.26 even, but I figured we'll just go a little bit over. Why not? Yeah. Wonder where and why did the imperial system exist? Metric is 100 years older than the imperial. Oh really? Yeah, I don't remember any of the history on that. All I remember was the documentary on it was on like the gauge blocks guy. I even forget the guy's name. But yeah, it's like all because of he like painstakingly did all this stuff, and I think there was a few things that became of that. I think it was surface finishes, and like there was a couple things. Yeah, yeah, exactly. It's like Google and the large language models have kind of ruined data retention for me. Like or factoid things, I could just go and look it up in like less than a minute. It's pretty amazing. I should probably watch that documentary again. There's actually another one too about like the really large machines. Or the heavy presses or something. I think it's called I want to say America's Iron Giants, but that might not be right. America's Iron Giants video. Some presses that the US stole from Germany after the war. Or it was the basis of that, something like that. I think they created their own, obviously, afterwards, but... Or maybe it's like England got one or two or something, the US, or the US got two, England got one, and Soviet Union took one, something like that. Hazy on my my history. Here, I'll throw this up in the chat. That's really good. And the other one is gauge blocks precision. Yeah, Carl Johansson. The Joe blocks. I think it was the origins of precision is what I watched here. Yeah, pretty sure this is the one. So the second one is about the gauge blocks, the origins of precision. And those are two really good channels too, by the way. If you guys like watching content about stuff like that. I'm going to watch both of those later. Good memory jog. Okay. Okay, so I got all that. These need to be recreated. Flat patterns. Again, I've done this 3 times now. So export. This is going to do, this is the big pattern. Yes. And we're going to do the handle as well. I don't remember if I actually did the other one, which is the reason why I'm doing it again. Oh no, did I put it to inch? Going too quick. Slow is fast. Loose is fast and on the edge out of control. Look at that, a panel we don't gotta fix. Activate. I don't think I did. Boo. Fourth and fifth time's the charm, right? Alright, then we have some updates now. Perfect. Probably have to update it again here. Yep, there's one more. Excellent. It's gonna save it now here too. So maybe I should have an overview and then do a couple of views just to zoom up, because it's these need a little bit more detail than what I can really give here. I could just say these are the hems, these are how long these pieces are. Yeah, I think that's what I'm going to do. I'll create some details. Ooh, go over a little bit. So standard hem can be there. 9, 10. Leave these for the other. That one too. I'm just going to blow this up really big in the corner there. But for these ones, we can say there's that. How I like to do all the different. Makes it look like I've done something on here. And the length of this one, I'm gonna leave for the other. That should make it look like it's symmetric. Okay, so I'm gonna do one here and then one on the end, I think. Yeah, good enough. So let's do saving, uploading. Let's do that many. Do that. It'll be like 1 to 1. Nice and big, so you can actually see it. Probably too big. 1 to 2. And same thing here. Let's do this corner. 1 to 2. So get these details here. And then I can mark it's like B opposite, you know, like that. And then the detail will be referenced sort of like that. I make this just a little bit bigger. So we can do, you can just have them off to the side, and we can change the name of them afterwards to be the same. So these are all going to be B. Oh yeah. So F. These are all B. Oh. B with a capital. B. I'm a B. This is going to be A. You do. Let's get this thing in place before I go and set it down here. Save. Sim opposite. Similar or opposite. Control. Okay. Oops, not edit view. So our opposite. Oh. Let me kind of know that all the, because it's all mirrored or reversed, so it's a similar opposite. And then we know where to put these things here. So the total is 0.058. That's the hem. So this is the hem, 0.029. I don't actually think that's right. Oh, 5.8. Why would that be like that? This is correct. 8.6. 8.6. 8.6. That's the hem. There's a convert. Maybe that's wrong. So on the hems, the hem is using the steel, and the steel is, oops. See, the bend radius is wrong for that. 0.0991, so it's using the wrong thing here. Can I do 0.039? Steel. Where's hem number 4? Ah, it's up top. It should be fine using the steel. Hem 3. Hem 1 is steel. Can I not change these? That thickness is not... that's not correct. Or, oh, I'm sorry. Yeah. Hold, please. What am I doing? .99. So 0.036 times. That's what it is. It is 39. So the hems convert. These should all have changed. Convert. Rebuilds. All right. Byte rate looks good and all that stuff. Make sure everything is looking okay. All right. Let's do the flat pattern on here. This pattern, flat pattern, should be actually a little bit larger than what's here because this is only a 90. This is 180, so yeah, there should actually be slightly more material here. That makes sense, right? Oh, but it's not drawn that way. It's drawn as a small, like a small radius, because I only have like 10th hour or something in between it. So if I add that in there, yeah, okay. And then they crush it down. It's still gonna bend and then crush down a little bit though, right? Is allowance for I think I used a inside radius. Just gonna go through that and just kind of check it out. As if this is your first time to my stream, thanks for dropping in and checking it out. I really appreciate it. If you like this sort of chill Fusion 360 sort of stream, I do this quite a lot. Yeah, drop me a follow if you want. And yeah, there'll be more stuff. Feel free to ask questions or lurk, whatever. I don't have a canned statement yet. I should probably work on that. Work on a canned stream statement for followers. All right. Welcoming message and first, then two photo? Something like that. No, not ending. I don't really pay attention to see who's coming or going into the chat. Just like I don't pay attention to the number. Maybe I should. It's like one of those like stream sort of things. So if nobody says anything I don't know, I just figure it's like, oh, if somebody's in here and they haven't followed yet, then please follow. Yeah, I gotta like, so I'm writing my notes down here. Well, it's like a canned like statement that I can say, and then figure out what to say at the end. At the end of stream, and so it's the same thing. Free time, and maybe the beginning as well. Format. Work on the format of the stream. Maybe think about some segments. What do you guys think about segments? Yeah, sorry about that. That's like one of the reasons why I'm writing all this stuff down. It's like, wait. See, that's proof right there that I need to do something. So it doesn't sound differently, right, than what I'm doing, because I just don't have any real concept of that, even though I watch streams all the time. Until you actually go and do it, you know. That hasn't dawned on me. Yeah, so starting stream thing, ending stream thing, how to welcome people into the stream, and like yeah, all that. And then maybe a statement to follow, like for follows. Geez, what else is there? There's probably a whole bunch of stuff. I gotta look all that up. Appreciate any ideas. Although, it's like, I don't want it to be like, I don't know, like everybody else's stream. I kind of want it to be just like my own stuff. But, you know, I think if everybody has like a certain kind of outline or thing that they do, then that's not a bad thing to conform to those, like, those little things, right? I need a new chair. Or I need to fix my chair, the other chair. Miss my task chair. This one is so friggin' warm, it heats me up like crazy. So going into summer, that's not a good idea. But yeah. So now my camera is slightly low. There we go. Not hitting my head on anything. There we go. Still good? There. Got my mic above me. I'm new to streaming, like, yes and no. So I did it. I've done it occasionally. I have some gear from when I started it in, when was that? 2018? I did a little bit of streaming, just like video game streaming, stuff like that. And then I just did it like intermittently for quite a long time, just like a stream here and there. But this is more like let's maybe try and build a community or something like that around Fusion 360 and maybe even engineering eventually, because I kind of want to get into a little bit more of that, engineering, math, physics, calculus, all those like fun things. I wouldn't mind to actually have some content on, because it interests me, and it's a good way to get into the like interactivity with the community in a more entertaining sort of sense. But I like working on projects, so like project oriented things are I think a better way to learn something. It's always good to learn something while you're doing something else. Fail fast, learn lots. Okay, I got all that stuff written down so I can stop thinking about it. And okay, I was just doing some reading on flattening hems and stuff like that. Let's see here. This is like the calculations of the bends that I was looking at. It's a piece of sheet metal folded back onto itself typically to create a smooth, safe edge and to reinforce the part. Flattened hem, also called a closed hem or a teardrop. So a teardrop is what I know it as, I think, from Inventor. All the stuff closed in teardrop. Fully compressed to the two layers are pressed flat against each other. Bend allowance for a flattened hem accounts for the material stretched and compressed during the initial bending. So as the flattening stage primarily affects thickness rather than the length. Okay. The material stretched and compressed during the initial bending process. So the initial bend 180, doubling back on itself, or less, slightly less. 135 to 150 before flattening, which makes sense. Very small, typical, well, for thin materials, precise tooling on a radius break or, radius break or press break. This defines the curvature of the initial bend flattening to near zero. Material thickness, however, the bend allowance is based on the initial bend's geometry, not on the flattened state. So like if you were to like compress it out and then it just squishes, it's the same. Okay. I'm thinking about this wrong. Maybe I did the hems wrong. Let me see. So I have this here. I'm going to isolate this so we can take a look at that. So what I had here, turn this off. Yeah, so what I had here was this is the original material. So it should be, if this was a normal bend, with this a normal allowance. So if the material is 0.036, like that, and the radius is 0.039, right? Or that's the radius, my bad. So 0.039 that comes around here is going to come all the way around here, so that's double. And then it's going to come back in on itself again. Some understanding here, right? And then when it gets squished again, I'm assuming it's going to be at this level here. So if I want it to be at this level, it's just going to compress and maybe grow out a little bit, actually. So at the top of this hem maybe should be designed like this, but the aftermath of that is not much. And I just drew it at 10 thou, I think. Was this 10 thousandths? Yeah. Or is it 5 thou? Come on. There we go. 5 thou. Yeah, 5 thou there. But in actuality, it's going to be flattened shape from these two. This is based on the original geometry, is what they said. So if this was to, let's see here. Is that? Oh, it's to the edge. I screwed that up. Let's fix this in place here so it doesn't move over. So as that comes over, so if it was like 135 from the bend, 45, that was the original bend, or even further, something like that, 150. And then it goes and it crushes that in there. What does that look like on the end? So I would like to think that it goes right down to this, but that's probably stretches all the way around and then gets crushed in. So it probably stays the same here. Inside radius defines the curvature of the initial bend flattening. So for okay, it doesn't have that functionality built into Fusion to do that. Although I could tell it that it's that, but it's not going to, I don't think, because it's not drawn at that. To get the extra material that's in there. Another rule for that. So even though it's drawn at this, it needs to have, or it could be drawn, I could just go like this, I guess. Have it instead of the other, instead of like flattened, it could just be drawn out like this. Because that's kind of how it'll go, unless it's like completely flattened, squished. So thicker stuff, yeah, I guess you could still do it either way. 0.3 to 0.5. Similar to the wrapping action that you've been visualizing. It's still the same formula. On the initial bend before flattening. .44. Apply the formula, adjust for the flattening. Compresses the hem, reducing the effective radius to near zero, doubling the thickness. However, the bend allowance is based on the initial 180, so no additional length is added for flattening in most cases. The hem is not a fully flattened teardrop hem with a slight gap. The initial bend may be less. So I guess how do I draw in CAD the flattened version of the bend, but have the flat pattern reflects the material bend, the initial and allowance I need. So yeah, it should actually be more than that. Or should I draw it as the tier, like teardrop shape like this? And that's maybe the best of both worlds, even though it's bigger. Because it's like a space like requirement. So there has to be like interplay between the two sort of ideas. Maybe this is the reason why one of the reasons why sheet metal is not considered great in Fusion, just for doing the hems. Or you just don't do the hems, you just add on an X amount and just do it. Or just specify it afterwards. It would be nice to actually show that though, and have the extra come out. I want to draw across the front hem as it's be finished. It won't calculate the bend allowance correctly. Is there a way to get around this without having to make two different bodies? So that's about the only way I can think about doing it right now. You'd have to have two. One generates it for this, and then the other one would go the other way. Yeah, it just won't do it. Yeah. So what are my options? I can do it. I need the material there. So I think I'm kind of I'm directed in the one particular way. So to redo this hem, thankfully, I could just switch it back and forth for whatever I want to do. But if I base the flat pattern drawing, I can't have two. So there's two drawings here. So the one for the tray should be well, the flat pattern should be from the one. I could just separate them, I guess. Or I can base it. I think I might be able to base it off the two the specific designs. Yeah. So I could just do like big hem, small hem sort of idea. Yeah, maybe I'll just do that. That's okay. So I'll modify these so that the hem is larger with the full extent here. And then when it unfolds, at least it'll get the excuse me. It'll get the full way around. That makes more sense. And I quickly eat the rest of my yogurt before it turns into milk. It already kind of has. Okay, so the original hem. Where is this one here? Where did I do that? Oh, maybe that was the original. Come on. Because if I was to he'll do what is this one here? Oh yeah. I don't want to save any of that stuff. That was just for funsies. So delete all that. And I could change the just the one here. this first hem. Where's the first hem? So roll it back to there. Oh, it is this one here. Okay. So before I get to that, let's do, we'll save the milestone. So save, this is going to be our flattened hem. Come on, to you, come on. So for this here, I should be able to, this is sheet metal already. I should be able to do a full hem. I want this to be a 1/2 inch and it's going to be 180. 90? Can I do a full 180? No, I can't. Okay, I'll have to draw it in. No big deal. What's all this stuff here? So this was 0.039 was that, and that's how it's going to come down. So all the way across. None of these should really be all that different. That's all really what it is. And then when it crushes, it's actually going to get a little bit long, like a little bit longer, or maybe not by much actually. So let me it's gonna go so it's not much bigger than that. It's a lot over further, right? And then that's going to crush in. So that's what I really need to have in here. And 0.039. Oh, this is also wrong. So this is 0.039. That's the radius. I knew it looked small for some reason. You know, Carzy. When you do this stuff here, it's just the order of operations. Radius. There we go. That looks better. It should be like huge. 0.039 radius. I'm always constantly checking down here in the corner what things look like. So that's appropriate. And then this, when I crush this down here, this will grow maybe just slightly. I think I'm okay with that, like what all that's going to look like. So if I was to go ahead in the program now to here, this is all going to be a little bit larger. Let me see if how much stuff this destroys. I might have to make this make the square a little bit larger, and if it's good, then I'll leave it. So see how much of the other things that this creates here. Let me double click that. So as it crushes out, this gets a little bit, oof. Oh, it doesn't have this thing on here, does it? There we go. Yeah, it needs to be a little bit larger. Okay, the hem on this one. So we'll go edit sketch. and make this 0.25, something like that. So it cuts out all the stuff. And then that'll get crushed back, and that will be preserved. And then this will all unfold correctly, or it should. Let me see all the way to the end here. All right. So let's update that. We're going to update this one too. We're going to do... I got to get this one done here. I'm going to double check this. I'm going to take a little break. I got to go to the bathroom and see if I have to get stuff started for dinner or something like that. So this one should be, yeah, 0.86. And then this one here should be 0.86 times 2 because this is 180 degrees, right? Which is very correct now. I looked at this, I'm like, man, it just doesn't look right for some reason. There should be more material here. Sorry. This is causing some strobing effect there. Inspects. Yeah, 172 double. And these should be just above that edge there. Well, that's great. So that I'm pretty confident with that now. So there's the flat pattern. For that is good. And while I was in there, I should export it. Inch. Any splines, convert it to polylines. We're going to overwrite tool tray flat pattern. Yes, save yes. Okay. Then we're going to do the same thing with the handle flat pattern. Let's do a quick double check here. 0.086, which is the same as that. Yep. And these two should also be the same. 8.6. I think these were 8.1s before, but they're all 8.6 now. Make sure I got all the rules correctly. So in hindsight, probably not the best way to go about, or it's not the best way to go about creating sheet metal if you're not really cautious about the when it converts the sheet metal bend, it creates a new rule for each one of those, and you have to make sure you're selecting the right rules. So as long as that happens, or you go and make that extra check, and then just check to make sure all those rules are good, we should be okay. So there was a couple mistakes there, and it compounded, and yeah, it just made things worse. Okay, so we're gonna save this as 15. Let's see here. I'm gonna do the 15. The handle looks big as well. For the hem, where is the... Oh, I didn't even do any section analysis on this. Crazy. Schmerp. Other side, yep. So we have the big starting hem. That's good. Turn off that. The handle's good. Where's section analysis? All right. I think I smell tuna. Let's see. Turn on the bodies again. The bodies and the fasteners. Yeah, it looks good. Okay. So I will be... Let me throw on here something. Can I do that from here? Let's do sketching. Eight, 10, 14. 3 sketching is pretty cool. I think we watched that one last time. Yeah, 3 sketch for frame design is really awesome. So let's throw this one up. Move this up here. Let's do is it window display capture? Oh boy, this thing's huge. Alright, so I will be back. Where's my BRB? Be right back. And I'll leave you with this for a little bit. Oh my, the silence. Alright, what do we got here? I'm back. Thanks for waiting. Or hanging out, I should say. I'm not really waiting. Let's see. Put that back on. Oh, it's super loud. That's better. Holy moly. Alright. Okay, so I got the hems all correct. In the drawings. So we're gonna update this. They should all have changed just a little bit. I think they did. Yeah. Number 2, they did not. Number 15. Oh, sorry about that. Where's this voice coming from? Holy shit. Give me all your money. Yeah. Good way to choke on whatever you're eating. So, all right. What are you watching on Netflix? I've been watching Netflix lately myself. I restarted The Blacklist. I don't remember most of the show, so it's kind of fun. What else was I watching too? I think Chaos? There's another show too I was watching. Maybe it was anime. I forget which one. Maybe you should watch The Witcher. They're really trying to push it on me. The Blacklist, 0 Day. I finished Black Mirror. I tried to watch Dark, but it's taking a while. Oh, Devil May Cry. That's what I was watching. Yeah. Watching some of the Studio Ghibli movies, or shows and movies too. I just watched, oh geez, what was it? It was about World War II, about the kids. Grave of the Fireflies. Holy shit, what a powerful movie. Oh, yeah. No, not a problem. Thanks for hanging out. That was awesome. Thanks for coming by. I try to do it every like weekday. And sometimes on the weekends, but more often than not, it's usually right around like noon to like 4 or 5 o'clock or so. Still kind of working on that, seeing what's a really good time to stream for this type of content. So far, like right now is okay. And then I might add to it, or like do like a 2-hour block and then a 2-hour block or something like that. Yeah. I really appreciate you stopping by and hanging out. That was lots of fun chatting. Let's see here. Okay. I have so 058, that's the old one. So these ones didn't actually update. This is not using the new one for whatever reason. So flattened hem is the last one. User save. Try 15. There we go. There's my big fat daddies. Thank you. All right. Much better, much better. I got all that stuff there. Got the overview. I got the major length here. The width. .039's the radius. So all that all looks good. You can do these from let's do from this outside edge to here. And then from the center line of this, I'm just gonna, it just shows that it's in the center. Jeez. What we got going here? I'm trying to decide how I want to detail this. These will all be like a similar sort of like template. I could probably do these as a template as well, like a one-to-one template. Let's talk. Tool tray flat pattern. I'm gonna have to close my window. Super cold. Holy moly. Drop the temperature real nice in here. Whew. Maybe a little bit too much. I'm trying to dial in my diet here. I find myself getting cold, so Oops, not BRB. The other one. All right. Interstellar. I don't need any of that. Finish properties. Asset finish. So if this was me, could I make it? No. Okay, so that's to the edge of the flange there. And I guess I could just say it's like hem, hem, hem. So standard hem. Right. So 425. As far as the hem goes, these are all, I should probably do, so if it's 0.039 is the radius, right? So 0.039, 0.086. Can I do 4.4? Can I add that to this? Bend table. Okay. Can I not? 0.044, and then they could just like, so when it's a ½ inch, 4.25. Why is it 4.25? Because it's a ½ inch total, right? Like a ½ inch flange. But if I wanted to like a full ½ inch, the full thing is a ½ inch, not from here to there. Right, so that's the design is a ½ inch, and then I have a 90-degree worth of bend allowance in each direction. It takes away from that, which makes sense. So it's from this, so 597 is the total, so that's where I put the tool on the edge there, or like an 1/8 inch out, whatever I'm using, sorry, the radius is 0.039 in from this edge, right? So that would be like the bottom of the radius, and then I'm looking at the 0.039, so it's actually 0.039 back from where in from wherever this is, because that's the bottom of the tangent where it actually starts curling up on the inside. But I believe Is this the outside? 0.086? This is the bottom, not the top. Ah, shite. Shit. Maybe I should do... Okay, so it knows that it's... So if these are all downs, maybe I can put them up instead? Because why would I show them down if I don't have to? It's just like it's mental gymnastics for no reason. Okay, so this is okay. I'm going to make this in the middle instead. So let's do... Can I edit? I don't think I can. I can't redefine it. So I'm just going to create a new flat pattern, but use the top side as this here. So it's going to give me all the inside bends. Oops. Or it should. So I'll activate that. Inspect. So this should be... It's the inside radius. So what did that work out to be? That was... these are 180. So 0.039. So to double check this, so it's 90. So 0.25. So 3.14159 times 2 times 0.25. So 1.57. So just get rid of that. Yeah. First part, and then that's multiplied by the K factor times the thickness, so 0.036 times 0.44, and then I'm going to add the radius, so 0.039, and then I'm going to multiply this by that number, and it should be 0.086. Should be each one of these legs, and that makes sense to me. Hang on 1 second, I just gotta make a call. All right. 0.86. So look at that, 0.086. It's like I did it on purpose, right? And then this total should be 0.086, which it is. This is all inside. Okay, so when I remake this, jeez. Export again. It's the same thing. It's just it's got different markings and stuff on it, so I want to make sure I get it right. Inch over here. This is gonna be the tray pattern. And then I'm also going, I don't think I have to remake this one. I'll do it anyways. Delete. Let's go into the handle. We're gonna make the flat pattern. So everything is bent up and over and then bent up again. And let's double check that. Right, 0.086. That's a 90. This is also, this is a 180. And then a squish. 0.086 makes sense. And there we go. So this is a 90 on the inside and then a 90 to 90 on the outside. So 90, 90, 90. Unfortunately, these are not, oh geez. These are not in line with each other. So they have to be individually done. One is slightly back from the other. Okay, close, finish, flat pattern. Reactivate flat pattern. I don't know why I'm talking like this. Handle flat pattern. Got lots of stuff in there. Alright. Close, and then we're gonna save beforehand. Right on. All right. Save it again. Why not? It would be nice to put a bead roll all the way around these, both sides, even around this too, like around the base. Man, I'd stiffen that up like crazy. So this stiffens it pretty good. In the middle would be like maybe even like 3 bead rolls, and then all the way around if that was possible. But maybe that might be more of a like a die or something like that. But if I was gonna do a stamping die, I would change the way that these hems look, I think. All right. So back to this. I'm gonna change this to see if it fully updates all the way over. Yeah, I knew it was gonna break everything because this is a new flat pattern. 172. Yeah, the 086, which is correct. So if they were to do this and then this, it's all up instead of down. Yeah. So at least all the other things are there. Oops. But none of these things are connected because everything is gone. They gone. Just too bad. I could just like go through each one of these and just go through the trouble of all that, but I don't really want to. I'm just going to delete everything. Actually, there's a better idea. I'm going to keep that. Similar opposite can stay. All right, we get the 4. I was wondering what that was. I was like, hey, how come this has changed? So the idea that I had was it's definitely the holes that I want to have here. Which makes sense to me, right? Right. Can I actually make this full size? Man, that'd be awesome. I could do this one here. It's not feasible. You could get the information across just with 1 to 2, or maybe even like 1.5, 1.5. Yeah, that works too. It's a little bit larger. So from this edge, it's like how do we detail all this stuff here? And from here, it's too bad that these are like this. It's very difficult to get these to go. And hole 129. One, two, three, 4. 1, 2, 3, 4, and then this will be 1, 2, 3, 4, 16 of these, if I'm not mistaken. 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, it's 16 of these. There we go. 4 times 4. And we got outsides, inside, these lengths here. Ooh. So we're doing all the layout. The layout's done before anything gets bent. So that's this guy here. So we're gonna do 4, 3. Oops. So that's the total bend allowance. And then we have 4, 3. And the other way, 4, 3, 4, 3. And then the location of that. Is 2. And then from the edge, R5, typical. One, two, three, four, 5, 6. One, two, 3, 4, 5, 6, 7, 8. 8x. So 30 degrees in that one. I think it's like right at the edge of that. Crap. That's the hole details. Hem width, and then there's extra stuff along here. That's actually kind of hard to detail because there's no edge there anymore. That's unhelpful, because I could go from here to here and that'll get it close, but these two, that's the actual bend, and that is not the right. It's 2.5, right? So it's actually larger, 15 thou larger than it should be. Maybe I should just keep those square for now. That's not the way it's designed, though. Let's figure it out. Well, if this is laser cut, it doesn't really matter that much. What does matter is the location for all these. So like the standard hem location. From the outside edge. And then I suppose I can detail all these outside edges. Yeah, so 1864. And then this next one here, the edge of the flange, right? This is also from here. So that gives the extent of where this is. So one and then 2 from the center line. And then also 1 and 2. So draw a line. And then now you have all these lines that you can go in here. And then from this, I can detail this line. Or I could just say, hey, it's from here. So here to here. That's this edge. That's your 10. And it's technically symmetrical. So that's placed in space from the center line here. This needs an overall dimension. No, don't. There we go. So from the edge, the holes and all that stuff. So we could say standard hem. Typical hem dims. Typical hem dimensions, which goes up on there. So that's done, and then we need to detail this. So from here to here, 425, here to here, 468, and on the inside. Yeah, so it's a little different because this is only a 90. Come on. The amount of clicking that you have to do in Fusion is crappy. Oh well. So this total is of the phalanges So 2.85 inches. And I'm gonna move this one up to here. 2.13. 2.86. 2.88. We could do drill after assembly. Do them before, do them after. It doesn't really matter that much, except the afterwards has to be extremely, extremely precise. Okay, so this is 90-degree setback. Allowances. This all has to be detail as well, which is right here. And this is typical, what do we want to call this? Typical, shit, I forgot what they're called. Let's go look up what those are called. When I have a flange that gets that tucked inside another flange. Hey, welcome back. Another face, another sheet metal flange, or face, so that I can spot or rivet to make a corner. What is that flange called? There's like probably a name for it. Nested flange, lap flange, lap flange. What are you up to this afternoon or evening? Just catching up on our previous conversation. I think it was yeah, you were outside once. The graphics are good, but the gameplay sucks. Yeah. What have you been working on these days? Have you been streaming too? I don't think I've seen you live for a bit. Jogged my memory here. Lap flange sheet metal. Said you were working on electronics, right? Yeah, okay, all caught up. Mostly weekends now. Started work, so pretty dead. Yeah, I get that, man. Work takes all my energy out too. That's why I'm trying to make a go of this. I got a little bit of time, so make the most out of it. Typical flange stems. Yeah. Yeah. Yeah, I feel that way a lot of times. Most of the time, actually. And I told myself I'm actually forced myself to start working more in public because it's helpful. It's helpful to talk to people while I'm working. You know, bouncing ideas off people and all the rest, like standard coworker sort of things, right? Let's see here. Okay, that's good. That's good. Typical flange dims. 511. Typical hem dims. There's that. These dims should be. That's a hem dim. Hem, hem, hem. Hem, hem. Okay, so that's from each edge all the way back. So I can do this one here too. From here, I have 5 down, so that can be a line across. And I have this one and this one. This will be 90, and then the hem dimensions are there. And I could say, let's do, I can do these back here maybe. All right. It's not, doesn't want to cooperate. So the extent of this one, I could probably do this because I have that point, and I could say R5. Yeah, typical R5. It's probably good that I separate these 4x and 4x. Not typical. Been home for about a year and a half to the mental health issues, so it takes some getting time used to. We are in a very similar situation, my friend. Except I haven't done anything substantial in about 5 years. Just little stuff here. Well, I shouldn't even say it's not substantial. I did work. There's 2 months or so. I went and worked, and that was what I previously did for a job. Was always on the road, and I was doing. I'm an industrial robotics programmer. That's what I did last. But I also do this type of work, like for pieces, right? So maybe over the past 5 years, I've had maybe 100 different things I've worked on. So it's not a lot. 25 a year is, maybe 20 a year or so. Isn't that a whole lot? Last year I didn't do hardly anything. So I I kind of feel you on that one. Very very similar. And it shows, right? It's like my health went like really down the tubes. And I'm trying to get that back. Trying to eat a little bit better, trying to exercise and just do stuff again. So yes, yeah. 22. I don't really want to give an angle dimension on this one. I guess I could. 23 degrees is about right. That's gonna not. Yeah, 23 is probably okay. I'm not gonna give an angle. No angle for that. This is gonna be the same, similar, opposite. Okay, I placed this one with this. I have all these things. This edge is approximately 0.75. Oh, that looks so horrible. Okay. I'll stop hemming and hawing. That does look better. To radius. For radius position. Outside trim, what do I want to call this? You know, it doesn't really matter. It looks kind of aligned. I can use that. What do you do for work? Or activity? I think you said you were going back to work, right? You started work. Yeah, that's good. Hem. Okay, so that's the edge of that flange here. Oh yeah, no problem. You're piercing the copper foil tape, yeah, I think. Yeah, unfortunately, I think that's very true. Okay, and the next one, did I detail that? From here, we have this one, 349. Sounds familiar, 349. So 349. I don't know if I can get this close enough here. Inside. Oh, you're a vehicle technician. Excellent. Diagnostic? Yeah, one of my best friends does that. Praise likes him. Hey, that's good, man. Take it. That's amazing. Uh, typical 90-degree bendums. So if I know where the center is, it's the center. Oh, people brag about you? Yeah. It's the thing about being, what they, there was a thing that I read. It was, exceptionally, like, people that are actually smart, know what they're doing, are humble enough to not, like, do that. So, yeah. When people brag about you, I have another friend, he kind of said the same thing about me a while back. He's like, dude, you gotta start talking yourself up a little more. This is years and years ago. And then so I did, like, but not, don't brag, like you're saying. It feels weird because it feels like you're bragging, but you're not. You're just telling people about your accomplishments. You know. Now, I like doing that too. I think it's good to like do it like once a day or once a week or something. Just tell like somebody that you like care about or hang out with. It's like, hey, check out this cool thing that I did today. You know, like I think that's good. It's good reinforcement for yourself too. You probably already know that. I constantly have to tell myself that I'm good at doing things because if not, I tell myself that I'm a piece of shit at doing it, which is not true. But that's just how the inside mind kind of goes crazy like that for whatever reason. Inside voice is an asshole. Yeah. Well, my inside voice, anyways. Let's move this one up a little bit. Be somewhere opposite. I'm going to try and... Oh boy. Move this over right to there. You probably shorten that up a little bit. ID doesn't need to be that big. Direction. Oh yeah. Yeah, I think if we don't do it, who's gonna do it for us? Right. Okay, so I think I got that. So first corner in, second corner in. So there's the line. Number 5. So I have 1, 2. Then I have the standard hem, which are here, typical hem dimensions. So 1, 2, 3. Got there, and then they can do the rests for those two. 1, 2, and then I don't have to do the total like that, but I'm going to. 1. So an inch between those two. Let's see here. Okay, we know what those are. And then we have a spot where this is. And we also know where this line is here and this line. So I just make that in here, similar opposite. B. Great. B, similar opposite. Same with these. Two. 12. I think I've heard this one already. I've heard all of this already. Let me see what else I got. Maybe a little Hello Nasty. You got a vehicle from another place about 2 months ago. They couldn't find the issue. After 2 months, we couldn't find the issue, and you love diagnostics. I got that vehicle within about an hour. I found the issue. Nice. Or more. I found the issue and managed to jump the contact, so it worked. But I still don't know the reason why the part is faulty. So they praised me and bragged on me to, oh, the new boss too, yeah, and stuff. And I was like, I found the problem, not the cause. Well, it's a step in the right direction, right? Even if it's only partial, it's still a great success because nobody knew what was going on with it anyways. You know, that's amazing. Good job, dude. Oop. Everything is legible. I don't like it when it does that. Money making, money making. 6, 7, 5. So that is now located. So when this, I have this location and this location, and also this line, and I have this edge. So this edge, in order to get, do I have the outside flange as well? And I have done an awful lot of drafting, not a lot of saving. Okay. So I went with this back edge. I'm thinking maybe I should go to here instead. Yeah, that's okay. I can do both. Okay, yeah, I did. So 420, 511 is the major. So go to here, and then 511 is out. And that'll give me all these things here. Maybe I should go to here. No, I'll go to here because that's the actually wrap over. Walking on and on. So from here, and then from here I can go 468, and that'll give me the 2 holes. Here 288 up. Okay, so that's all buildable, and then all of these are the same or similar opposite. As long as I got these corners 1, 2, 3, 4, and then from here to here, obviously, it should be the same. It's 12, yeah. Overalls in the middles, and then same with here. Stereo. Then we have all the different bends, so 90, 90, 180. Typical O's 167 degree hem. Yeah. So hem dims, flatten. But it's like you looked at the wiring diagram, you measured, you found an input that you didn't get 30 constant. For me, anyone could have done that. But since it's Renault with a Fiat emblem, I can't find where that wire goes. And since we've done changes and stuff, I can no longer get to the Renault wiring diagram. They praise me for finding the issue. Well, I complain about not knowing where that wire actually goes to fix it. Ooh. Yeah, thanks for that. Yeah, exactly. Let's talk about changing the schedule tomorrow. So tomorrow I have diagnosed an MG that won't charge. High voltage battery. That's electric vehicle. High voltage battery. What are usually the problems with that sort of issue? Like a contactor fault or something like that? Or is it like a short in the battery, like a shorted battery cell or something like that? Or oh, MG only does EV now. Okay, gotcha. That's cool. What was the other thing I was thinking of? Unbalanced battery? Unbalanced? Yeah. Eh? Do. I think this is good. Although crammed in here. Spent like all day on this. Well, not on just this, but other stuff as well. Just finagling and stuff. There we go. Let's see here. During the normal charge, they're balanced too, but when fast charging, oh, it doesn't. Ah, very intriguing. Guess I'll put some notes. Bullet point. Break all sharp corners and edges. Considering it's sheet metal, it's like a okay. Flatten hems after flatten all hems. If manual layout, you can drill holes after bending. I'll leave that up to them. That's more of a, hey, you know how to do your job. No. Good enough. So tool tray, these are the overall dimensions that so this should only do can I choose which one this is? Yeah, I want to use 15. Use. I think it's 15. Oh no, it's even older. You know, I could have just used the flattened hem. Milestone. There we go. So 14 is there. I'm gonna save that. Now hopefully all are you kidding me? Okay, well, I'm not gonna do that. That was so many. Okay. I'm just going to create another drawing. Save. Export PDF, all sheets. I'm going to open up the line weights too. I used to do DXF drawings too, but I don't want to do that anymore. Get you out of balance, you can't charge it by fast charge, but this shuts off either way. So you're thinking DC to DC charger, or maybe an issue with the interface talking to the car and charger. Coolant pump. Wow, could be a whole bunch of stuff, eh? I'm actually really surprised there's not like a full on-screen diagnostic like in the car that you can use. That'd make everything so much easier, right? Like you could see like what everything's doing, like a page's worth of diagnostic. Or maybe there is, and it's just like, wouldn't that make sense? Like, instead of hooking up a scan tool to it, because you have computers in the car, why not just use the car? And then on top of that, you could just do like a whole, like make it like an HMI for everything. So that would make way more sense to me, but maybe not. It is a really sophisticated machine. Like if it's got a lot of stuff in it, why wouldn't you do that? Or like you know, like a dongle or something that you need, like a master key or something. No idea. Yeah, if you know how to do it exactly. Yeah. Uh, okay, we're exporting the PDF. So let's put that in the PDF in the drawings. This is flats tool tray flats pattern. Yeah, it looks good. And there's dimensions here, which should be on the outside, but they're not as clear as the one here. So 49. I should be able to turn off the line weights too. I don't think you can do it in Acrobat though. You can do it in other programs. So let's do, we have the assembly. So tool tray drawing. Is that all I need? Yeah, let's rename that tool tray flat pattern. Tool tray assembly. Sounds so soothing. Body moving. Oh, the assembly is where the drawings are made from. We're going to use get latest version. But technically it should be, yeah, because that's the assembly. 17. 14. The handle on there. That's good. And the drawing. So 11 to 14. Yep. Perfect. So this should give me the overalls of everything here, and that's all I really need. 10, 12, and all that stuff here. It's the same information for the handle. And then yeah, it's all the same information. 90 degrees and all that stuff. Android base, so you can screw up a lot of stuff through the head unit. Oh yeah. Ain't that something? Yeah, it's pretty amazing the amount of software that's in a vehicle now. Like that's something. Assembly should still be the same. I didn't really change. I don't think I changed a whole lot. As far as that goes, we'll go to tool tray drawings. It's the big one. Tool tray assembly. Yeah. Very straightforward. And I'm gonna do the handle flat pattern. Where is let's do that. Create a new drawing. I'm gonna do a flat pattern. I'm gonna do all the same stuff here. Inch, horizontal, flat pattern from a scratch. Three, two, three. Yeah, actually, we'll do two. Big long things here. I might even do 1 to 1. Let's do. I should be able to do break view. Yeah. There we go. G5. Nice and close together. Up and away. So there's a little bit more room for this stuff here. Interplanetary 10. We gotta do some of this stuff here, change that. Units are fractional. No, I did decimal on the other one, didn't I? 3. Angular position, linear is 3. No inch. It's only been like 5 minutes and I forgot what I did already. Yeah, 3 on the one here. Okay. Typical hem, and then we can do, these ones are gonna be a little different. And then here, sick these out to there, and then to you, and then to you. The worst part, we had some dumbasses trying to steal our 8 of your vans. Holy shit! They basically did is brick them. No. Give it a fake key through the OBD, but instead they cleared everything for the. Oh yeah. They basically bricked them, and with that, I found out I could steal them within less than. Oh geez, all you need is 1.5 inch piece of wire and a big screwdriver with a wrench around it. Oh my goodness. Not even your 2000. Yeah, your 2008 Caddy's not even that easy to steal. Well, if it's a Hyundai Kia, then I understand. There's a lot of that going around, actually, or was over the previous generations. But you're saying MG, right? It's this is not good. So these ones are the same, typical hem. So these are here. $95. Oh, there's so many things in this. How many? One, two, three, four, five, six, seven, eight. Two, eight. Actually, I'm gonna bring this one over here instead. Maybe I do the these patterns over here instead. Yeah, it's already done. Do. BC boys. Actually, what I should do is do the $838. Just do the one dimension. All right. So overall, and then you have all these dimensions here. Oh, the Fiat and the Renault. Okay, literally just a big flathead in the ignition. Oh yeah, with the wrench to leverage it. Oh, okay. Turn the ignition on, the alarm off. Open the hood, use a wire to jump the fuel relay, and then screwdriver on the starter. You could just turn the key to start it because all that immobilizer did was shut off the fuel relay. Oh, wow. Yeah, that's true. How would I feel about this drawing if it was given to me? So, I've got a whole bunch of things here. It's like I could do the typical set on this one too. I just drew it in place instead. So one, this is a 1/2 inch. Yeah, all right. I'm gonna do. Yeah, I'm gonna do the zeros here. Come on. Should always put it on the outside. Half. 495. Anyway, 4. $25. Come on. So that's from the outside. I did it wrong twice. Actually no, because I want the 901s on here. Oh no, I did it right. So 8484. And then I want the overall. Oh, that's not right. Flange to flange. Overalls. On the small ones, the large ones are there, which I have. These ones are to the outside, inside, so you can get the difference. And then I'm gonna go straight through here, so 511, then from here to here, and then from here to here, and then also back from here to here. Come on, fusion. Get all the centers there. And one of these. And one of these. And a total. Set a total, please. There we go. All right, man. Yeah, have a good one too. Great chatting with you again, and I'll see you another time. I'm getting ready to also eat 8x, big 8, big X. 129 through, and this has similar sort of stuff to it. Ugh, come on. $4.95. This is so messy. 1DJ. Come on, Fusion, you can do it. DJ. Should go to the other side here. Man, that's a lot. That's a lot of dimensions. Tool tray, handle. Save. Tool, tray, flats, pattern. Standard hem dims. Why do I always have to overcomplicate shit? Typical. Typical flange, what do I call this? Is it typical bend? Did I even say that? Yeah, typical bend dims. Flatten all hems. Busy. Hole located. Holes located. Hole located. Located. Located from the outside. Okay, I can make that. I can make this one. I don't actually want this here because I don't want someone making that mistake. So it goes from the outside. Put this flange here. The 881 is actually what's really important. From the outside to here, do those ones, and then from this side here, or the small one, go out to that. So this is placed off this one here. So that's the big one, and then these are the small ones. And that just happens to be the overall. These are the inside ones, 738. I don't have the length here. And then I do have that one, so 968. I don't have an overall here though. Do I have an overall? Yeah, I do. So 25, whatever that is. And then this is the 2554, which is the overall of the small one. Okay, that's good. And then from here to here, here to here. I don't have one of these. Same thing with this one. 2554. I'm wishing I would have done the details now. Well, it's buildable, I think. Okay, so can I build this? 1, 2, 3, yes. These are going to be similar or in line with each other. So I'm just going to measure, I'm just going to do that, detail that offset. Everything else really doesn't matter that much. That is not the correct one. There we go. It's hard to see. And I keep the other one. E38. It's 2554 I already have, but the middle one I don't have up here. That's actually what I wanted. E38. And typical bends here. These are all 90s and then a couple 180 hems. Right on. Save that. Handle. Oof. It's almost time for me to go make some dinner and hang out for a little while. So this one is pretty much done. I open the PDF afterwards. Should be good. And tool tray handle flat pattern. Save. Excellent. Looks good. Lots to look at. Don't save. Okay. So for this, do we have all of the other drawings? I think we do. This should be ready to go, I think. 5 packs. Tool tray. Uh-oh. Maybe I should get rid of these and do that over again. Flat patterns, drawings, good. This is there, and I will do export it again. Handle. 4. So step STL1, handle 1, and the tool tray. Oh shit. I don't want to create a new project. It's cool though. Redon. I'm going to put the mass on here. Assembly. Electrify, electrify, electrify. Where's my assembly drawing? So this is not the right at the title block. I don't know why they want to do the the weight is not correct, I don't think here. So attribute, it's like mass, if I'm not mass. .1 pound mass. Yeah, so for this thing being huge, 7 pounds actually isn't that bad for a big ass tool tray. Export PDF. Tool tray assembly. Yep. Right on. So then the rest of this stuff here, we can do. Oh, there's a lot of stuff over there. I can bring you guys back over here. Tool tray is. Tool tray. Actually, maybe I'll do that later on. Something like that. Okay. Well, we had some. I had some fun today learning all about more about sheet metal, about how the calculations are done, why it works that way. So I got like a lot of personal benefit in figuring out figuring out why, like how the calculations actually work for all the sheet metal bending and stuff. And then on top of that, what you actually need to detail on the drawings. So the only thing that I didn't do was put a sight, like an actual sight line on there. And what that is drawing. If you have rounded tooling, or I don't have rounded tooling because the thing is it's so small. I could have actually put that on there, where your eyeballs. So I just go into the front here. So I'm just going to draw it exaggerated. So if this is your tooling, your big tool, it's here. Let's say something like that. Right. So that's the nosing of the tool that you're using, and you have a piece of metal, like sheet metal, that's underneath this, right? And you want to make it so that this piece flows around. You need to have, so here, in order to line up like the edge of wherever your bend starts and then goes over, so like where this would be, let me bring that up here. You need to, oops, you need to be able to look down the tooling. So if your bend starts way back here and ends up like this, so that's like where the edge of the tooling is on the inside. This is your inside radius, but it starts back here. You can't see that. So you have to go over whatever the radius is from the start of the bend. So in your drawing, the drawing, right, is going to have the 3 lines for the bend, right? So this is where it starts. The theoretical midpoint, which would be this one. That's this one here. Come on, derpies. Right. This one here. So you have your bend start, which you can't see. The theoretical actual point. Well, technically it's that, but not really. So because it's I'm sorry, what was the bend allowance is different. That's right. It's a little shorter. Like this. My bad. Because usually it's like whatever nosing. Oh geez, I always forget this part. Holy shit. I'm gonna have to look it up again. It's good that I'm like redoing this because it's what do you call it? Space repetition or recall. History. I watched some of this morning. Oh no. Oh, that's right. I didn't watch it on my account. Boo. Oh, okay. Well, it's the first one that came up. How awesome is that? Okay. So adding a sight line. So the bend radius, like if it's a 1/4 inch or if it's different, like from the edge or whatever you're doing, so the tool that you have in there is going to create a new radius. That doesn't make any sense. It should just be in the middle anyways. You're looking straight down, right? Yeah, because you want to look straight down on it. Oh, I think this is just make sure you highlight them. Use an X to highlight so you don't forget which one that you're actually sighting in. It doesn't matter which BTL you measure from, but whatever one we pick needs to go under the call. Is that the call? So tangent bend lines. Yeah, because you can't see the tangent. That's the idea. So the two bend lines. So yeah, it's because you can't see the one where this starts, and then there's the middle point, theoretical middle, and then the end point here. So you always have like you have a line that goes around like this, and this line here is not going to be the same as the other because the metal stretches around, shrinks and stretches, and it's 0.44 and not like at this line here. So realistically, if you wanted like that radius, actually it's maybe not right to say that, this radius here from here all the way around the inside and then out to the outside. So in order to get that radius, the material length is actually different than from here to here and here to here, right? So it's just it's inside a little bit. It looks like that. So your sight line is this one here, right? So which would be like right here. So that's the idea, because it's not the same material that goes from here to here is less. So like if you were to go to like, I don't know, like halfway in between or something, it's this, you could actually draw it out, I think, just like that, but it's not quite the same because of where the radius that you're actually using is. The center line radius is like in here, and that is called shit, it's on the tip of my tongue here. The neutral axis. So this is what axis is it going from. So that's technically where the bend sort of is that we're calculating. So it's technically like here, wherever, like the center of the bend. It's over a little bit, something like that. So as it goes around. Yeah. Something like that. I don't know. I do know, actually. That's what that is. I gotta stop saying that. Right on. I'm gonna go cook some dinner. It's 5:30. Or prepare some dinner anyways. I don't think I have to cook anything tonight. I think I'm just warming up leftovers. Very tasty. I do like leftovers. Probably some yogurt again. Yogurt, fresh raspberries, strawberries, blueberries, something like that, or maybe frozen, something like that. So yeah, that's the sight line. So as long as we can see the tooling and where does that go, and that's the radius of the tooling, actual radius, and then right to the edge, which is like if it's a 1/4 inch or something, then you know, that's what it ends up being. Yeah, we can just mark that on the page or mark that on the steel, so when you go under, and that's the line that you go to. So whatever, the way I detailed this is that I'm detailing like the tangents of all things, but I didn't actually do that because I would want the person that's doing I guess I could have put it on the drawings. You mark the sight lines, so I could do sightline drawings, and that would be from the back of this, and I could just say all sight lines, or I could say sightlines for this radius are at X amount, but they might have a sightline dimension already for that, for the material that they're bending, and on there. So it really doesn't matter anyway. So as long as I have the start, the middle, and the end, wherever they want to put that through, they have the information. So all the offsets. I think that makes more sense because that might be a little different shop depending, because the sightline depends on the tooling that they're using, the actual tool. So, but if it's made for, I didn't use the minimum radius, I don't think, because that would have been 0.0. I made it was a little bit larger, so I used 0.039. It could have been actually smaller than that. It was where's the table? I could have used 0.26, but the recommended was this for 20 gauge. I don't think you'd want to go smaller. That's like crushing the thing a little bit. So 0.039, which is basically the same size. The end of the tool has to be like pretty much that, like a sharp, fairly sharp edge, to do that. So like the edge of their tooling is probably not even that. I would be very interested to see if it was 40 thou or less. In a lot of places, it's probably like up here, right? So your inside radius 0.125, 0.118 for all these. I wonder if these are established somewhere. IR, internal radius, and bending forces. Because if you had like 0.12, like 11 gauge or something, or quarter inch, you're at, so inside radius 0.328. Where does that come from? 0.328. So quarter inch, 0.328. Or that maybe that's just what it ends up being. It's 0.375 or something like that. I should look into that. And then 15 tons per foot. Yeah, it's cool. So a little bit more to do tomorrow to figure out. Do some more sheet metal, maybe some more calculations, maybe even do like that repetition again. If not, I wouldn't mind to like do another project. That project was fun. Doing all the rest, and another detailing projects for that. I'm gonna put these on the website tonight. Maybe I'll do that after dinner. While I do some other stuff. I'll get that all ready. Maybe do another detail or something like that, or another rendering. Let's see here, 0.036. Oh, that's just all. It's all the same thing. So 0.039. Thicker sheets require larger radii. That's minimum radius, I think. Minimum bend radius is the thickness of the sheet metal and the type of material used. Below is the table summarizing the method. Minimum bend radii for different materials, including aluminum, steel, stainless steel. So steel is 0.8 times the thickness. 1 to 6 mil, 6 to 12, 1.2 times the thickness, and 1.5. So steel, imperial, and 20 gauge. So 0.039 is slightly larger. That is not 0.8 times the thickness. Because 0.8 times the thickness would be bigger, wouldn't it? No, smaller? Yeah. 0.02, and that's minus the other one. Airbending force chart. It's nice to have these numbers here. Yeah, 0.026 to 0.079 is desirable. IR 1079. It's 120. 11 gauge 105, that's it's a quarter. Inside bend 7.2 tons per foot. V is the opening, so it should be at least an inch. 0.95, and then B the leg, or minimum setback, minimum leg length, I guess, is 0.709. Okay, well, that's all really helpful. Excellent. All right, thanks everybody for showing up today and hanging out with me. That was like really fun. I'm gonna have to come up with something to say when I'm beginning, ending the stream, and welcoming people in, or getting people to follow, or whatever else. There's probably some catchy lines I can use for whichever. Appreciate you coming to hang out. Thank you for the follows, and thanks for the good conversation. There's had lots of those today. Way more messages than I normally get, so that's man, what an honor it is to hang out with you guys. So thank you very much for that. I really appreciate it. So I'll catch you probably tomorrow.